Let's begin chapter 7. This is operation on functions. So we're going to be revisiting function notation, which we had done in chapter 2 rather. And it's just going to be like we had done in chapter 2, and we have been dealing with polynomials in chapter 6, so more of the same here in these two sections that we're going to do of chapter 7. Section 2 we'll get into inverses, but we'll use methods that you have used before. So the biggest thing is for you to remember that when you see the f of x, the g of x, and the h of x, these are labels, these are instructions. This is the name of this function. It is f. This function is g. This function is h. And then tells you what to do with it, what to evaluate it at, what you're going to use for your x value. First, we're going to do operations. We're going to add two functions, subtract two functions, multiply two functions, and divide two functions. The only time it gets dicey is when we divide two functions, then we need to think about the domain. And we'll go into depth in that when we get into class. So we're going to take the function f, 3x plus 1, and the function g, 2x minus 3, and perform our operations. So you'll see what they look like here, where we add, subtract, multiply, and divide. That's what they look like. Pause as you need to. And it is combining like terms using your distributive property. And of course, when you divide, when you look down here at the bottom of your screen, there is nothing you can simplify. When you have two polynomials, you have to have exactly the same binomial, top and bottom, for them to completely cancel out. You can never cancel out terms. You can cancel out factors. Here's what I mean. This whole 3x minus 1, this is a factor altogether. So you need a whole factor of 3x plus 1 to cancel that out with. You cannot go, oh, look, the x's match. We cannot divide those out. And you can't go, oh, look, there's a 3 and a 3. No, because that 3 at the top goes with 3x plus 1. That is a whole factor. And then the 2x minus 3 is a whole factor. It needs another matching 2x minus 3. So you cannot cancel out the terms within those. Anyway, so you have combining like terms on the first two, and then distributive property, double. So 3x to both terms, and then the 1x to both terms. Now let's look at what are called compositions. You are going to evaluate a function, add another function, rather than the numeric value, and you have actually done this. So let's say they, instead of just giving you 2x plus 7 and negative 5x minus 1, they just name two functions. And you are going to put the second function, negative 5x minus 1, in where the x is. You've done this before for like a 2a or a 3q. You've put in. This is just slightly longer. And I think you have actually done one that was a little bit longer before in chapter 6. So do f of x at negative 5x minus 1. So that's what you replace x with. And so then you do 2 times all of that function, and then add 7. And so you see how that simplifies down. And so when you evaluate f at negative 5x minus 1, it comes out to you a negative 10x plus 5. I wrote this a very long time ago. Perhaps this second one should have been a g. Now, it actually has a real notation when you do compositions. It is called f of g. And I believe that's where this tiny little circle comes in. So you're thinking of the first letter of. So f of g of x. And this is the older notation that I'm accustomed to that was in your previous textbook. Well, not your previous textbook, but the textbook that preceded the one you used. You might see these two interchangeably depending on the age of the problem that you get. Anyway, when you do f of g of x, you'll see it down here at the bottom. It means you're going to evaluate the outside function is the one you are evaluating. I'm going to evaluate the function f. What value are you going to evaluate it at? The second one, g, is the inside function. So that's your value. So I want to evaluate 2x at x plus 2. So I put x plus 2 in the place of x. So I'll do 2 times the quantity of x plus 2. And then that comes out to 2x plus 4. And that's it. That is function operations and compositions. So we'll go delve into that more deeply in class. Slow it down and take as many notes as possible so that they are complete for your questions.